Okay, for the introduction, elements combine in fixed ratios to form compound. For example, consider the compound aluminum chloride, which is AlCl3. Each molecule of AlCl3 is composed of exactly one aluminum atom and 3 chlorine atoms. Now for the purpose. The main objective is to synthesize and determine the empirical formula of the product of a reaction of zinc metal with solid iodine, and to determine the formula of an unknown hydrate. In Part A, you are asked to determine the chemical formula of a compound that is composed of only zinc and iodine. And in Part B, you will determine the number of moles of a water hydrate along with the determination of the identity of anhydrous salt produced. Also, the formula of the unknown hydrate compound. The materials we used for this experiment are beakers of 50 and 100 milliliter, a hot plate, your unknown hydrate which is provided, zinc metal in a powdered form, iodine, 2.0 moles acetic acid, the crucible and its cover, Bunsen burner, iron ring and iron stand, and wire.
Alright, for the procedure of Part A, you weigh out your 50 or 100 milliliter beaker and record what you got. For us, we used a 100 milliliter beaker and got 48.95 grams. After that, we added approximately 0.6 grams of metallic zinc. We weighed the beaker and the zinc together and got a mass of 49.82 grams. We then subtracted 49.82 grams with the mass of the beaker and got 0.87 grams of zinc. We took a piece of weighing paper and weighed it and got 0.39 grams, and then weighed out 0.6 grams of solid iodine. With the weigh paper and the mass of the iodine, we got 1.15 grams. For the mass of the iodine, we got 0.76 grams. We added the solid iodine to our beaker containing the zinc, and next we added 5 milliliters of 0.2 molar acetic acid. We swirled the beaker occasionally while recording our observations. The reaction was complete when the solution is colorless. You can tell this by placing the beaker on something white and seeing if there is any color left. After the reaction, there will be excess zinc. Carefully decant the solution into a clean, dry 100 milliliter beaker labeled unreacted zinc iodide product. Save this until the end and make sure the remaining zinc remains in the beaker. Add about 3 milliliters of 0.2 molar acetic acid to the beaker with the solid zinc. Swirl a few times and decant most of the solution onto your product solution beaker, but leave the solid zinc in the original beaker. You have just washed the zinc. Do this 2 more times for a total of 3 washings, then wash the zinc with DI water. Discard the DI washings into the collection beaker. Now dry the remaining zinc, put the beaker with the moist zinc on a hot plate and gently heat until it appears dry. The weight of the 100 milliliter beaker ended up being 46.84 grams. Remove the beaker from the hot plate and allow it to cool. Weigh the beaker with the zinc. For the first weight of the beaker with the zinc, we got 49.59 grams. We heat it again on the hot plate for another 5 minutes. Remove it and let it cool down. Weigh the beaker with the zinc in it. To be done with this experiment, the mass of the zinc has to be with 0.01 grams of the first weight. For our second weight, we got 49.58 grams. If it is 0.01 grams away from the first weighing, repeat the heating and cooling and continue until the mass does not change more than 0.01 grams between heating.